So here most of the questions are related to the concept of tangents and normal to the parabola. And yes, few questions are there which is just very basic. So let's take few questions which is not related to tangent and normal, and then we will be discussing the question which is related to tangents and normal also. So let me take few questions. Just a moment. All right. So the first question is the length of the chord of the parabola x square is equals to 4y, having equation x minus root 2y plus 4 root 2 is equals to 0 is. We have to find the length of the chord over here. And the options are given. First option is 8 root 2. Next one is 2 root 11. Option C is 3 root 2. And option D is 6 root 3. Okay. So let's do it. Here we have to find the length of the chord of the parabola. The equation of the parabola is given over here, and chord is having this equation. This is the equation of the chord. Okay. Length of the chord we have to find. So when we are talking about this parabola, that is x square is equals to 4y, our parabola will look like this. Vertex at origin, x square is equals to 4y. Yes or no? This is how our parabola will look like. Do you know that?
Yes, ma'am.
So now we will be drawing a chord in this parabola. So maybe the chord will look like this. Okay, length of the chord we have to find. Okay, this chord's length we have to find. So there will be two point of intersection. Let's say this is point P, this is point Q. So length of this PQ we have to find. That's called chord of the parabola, right? So let's find it. So first thing first, we just want to find the point of intersection P and Q. Okay. So how we find the point of intersection? When we were solving the question from area, uh, by using integrals and all, we were finding the point of intersection of curves and everything. How we were doing that? We were just doing the substitution, and we were solving it to find the point of intersection. Same thing we will be doing it over here. Since we want this point of intersection, this is PQ, so that we can find the length of the chord. Okay. So let's solve. We know the equation of the parabola. We know the equation of the chord. We are having equation of parabola as x square is equals to 4y, and we are having the equation of the chord. If we will customize, if we will do a little bit of arrangement over there, the chord equation will look like this one. X equals to under root 2y plus negative 4 root 2. Okay, I have kept x on one side, and rest of the terms I have shifted to another side, so that we can take the substitution x from here and we can substitute it in our equation of the parabola. Yes, let's do that. So root 2y minus 4 root 2. Here I am going to substitute x, which I have got from the chord equation. Root 2y minus 4 root 2. That's a square is equals to 4y. Basically, point P coordinate will look like x1, y1. Like x coordinate will be there, y coordinate will be there. And point Q's coordinate will look like x2, y2. Okay. Now let's do the simplification and let's solve it. So we will be having a square, that is 2y square, minus 2ab minus 2 into a times b plus b square, that is 4 root 2 whole square. Okay, 4 times 16 and root 2 whole square will be only 2, that is 16 2 times 32. Yeah, is equals to 4y. Let's move ahead. Now here we are having 2y square. Here we are having 2 times 4 8 16. So we are having 16y. Please do it with me so that we will not miss any number while doing the multiplication or anything. This 4y, if we will take it to this side, it will be minus 4y over here plus 32 is equals to 0. Okay, so we are having 2y square, 16 17 18 19 20, so 20y plus 32 is equals to 0. Here we can take 2 as a common, so we will be having y square minus 10y plus 2 1 times 2. Yeah, 16 is equals to 0. This is one of the equation we got. What we want to find? We want to find y value. Since this is quadratic equation, two values of y we will be getting. Yeah, that's what we need, y1, y2, right? So here, if anyone who have joined just now for them, here the question is the length of the chord of the parabola. This parabola is there having equation. Chord is having this equation and we are supposed to find the length of the chord. Here I have plotted the parabola and chord, a random chord I have plotted, and we are saying that we want this length of the chord PQ. That means first thing first, we need the point of intersection P and the point of intersection Q. If we will know the coordinate of P and the coordinate of Q, easily we will be able to find the length of the chord. Okay, for finding the point of intersection, that is P and Q, we are solving this two equation, parabola equation and the chords equation, by doing the substitution, and we ended up getting this result. Okay, now here this is quadratic equation. Once we will solve it, we will be getting two values of y. Obviously we need two value for the point of intersection, two value for y, two value for x. So here, rather than solving this equation, like, we can solve it. Okay, we will think about solving it either by factorization, by splitting the middle term, or maybe by using any formula. Let's see whether by doing factorization is it possible or not. So factorization, this is 16, 8 2 times 16. So we got y minus 8 and y minus 2 is equals to 0. Okay, so y value we got as a 8 and 2. Let's find x values. So we can use any of the equation as we know. So let's use equation of the parabola. X square is equals to 4y. X square is equals to 4y. When y is equals to 8. Just a second. X square is equals to 4y, equation of the parabola we have taken. When y is equals to 8, x square is equals to 432. X square will be root 32. Okay, and here we'll be getting plus minus under root 32. Fine, let's keep it as it is. Let's take the other y value, that is 2. So in the same equation, if we will be taking 2, let me check if we will put this y value in this equation, in the chords equation, what we will be getting first. If we will put it y value, that is x minus root 2y, x minus root 2y plus 4 root 2 plus 4 root 2. One of the value of y is 8, one of the value of y is 2. Okay, from the equation of the parabola we are getting root 32. We can simplify it again, we can factorize it again. Here we are getting two value from here, and maybe when we'll be taking y is equals to 2, again we'll be taking two value. So we will be having four value. From there we need to analyze which coordinate we will be taking over here. If I'm substituting the point over here, let me check what we are getting. So if we will substitute it in the equation of the chord, we will be having 4 root 2 is equals to 0. That means x equals to, here in this side we'll be having minus 4 root 2. That side it will be plus 4 root 2. Okay. If we will be taking y is equals to 2, we will be having x minus root 2 into 2 plus 4 root 2. So this is equals to 0. This side it is becoming plus 2 root 2. If we will just change the side, it will be minus 2 root 2. Okay, this is what we are getting. All right. That's how our coordinate looks like, one in the first quadrant or other in the second quadrant. So maybe these are the points which we are having x, the points which we are having as 4 root 2 and y is 8, and the other point is minus 2 root 2 and y is 2. Okay, let's take this 2 point. Let's say this is p, this is q. Let's take this 2 point and let's find the length of the chord, and let's see whether any of the option which is given over here, that is matching or not. So length of the chord PQ will be under root x2 minus x1, x2 minus x1 whole square plus y2 minus y1 whole square. All right. So we will be having 6 root 2, that means 36 into 2 plus 36. All right. If we will, we can do the multiplication and then we can add it. Otherwise we can also take 36 common and we'll be having 2 plus 1. So 36 we can take common and we will be having 3 over here. 36 means 6 will come out and 3 will be remaining. 6 root 3. Yes, it's there. Okay. So let's summarize the whole concept, what we did over here. You can simplify this part, this line, you can simplify the way you want. Okay, eventually we will be having 6 root 3 only. All right. So what we did over here, the length of the chord of the parabola, this one, having equation this. Okay, having the chord, this is the chord's equation. So if we are having equation of parabola, we are having equation of chord also. We just have to find the point of intersection. 2 point we need so that we can find the length of the chord. All right. Here we have solved the equations. When we and easily we got y value. When we substituted y value in the equation of the parabola, we were getting a lot of different possibilities. We have avoided that and we have taken the equation of the chord only. Okay, equation of line. There we have substituted y and we got two coordinate, that is p and q. One in the first quadrant, another in the second quadrant. That's how our figure also looks like. Okay, this is the just the rough sketch, but this is how our figure looks like. So we got p and q, we just have found the length of pq. That's it. Is it clear to everyone? Is it clear? Yes or no?
Yes, ma'am.
Okay, now as I said, a lot of questions are there which is related to the concept of tangent to the parabola. So let's take one question. Just a moment. Okay. So before taking the question, let's take this concept. From here, we will be just finding one rule, and that rule, that formula we are going to apply when we are having the case of tangent to the parabola. Okay. So let's say we are having equation of the parabola, that is y square is equals to 4ax. Okay. This is how our parabola looks like. This is how our parabola looks like. Let's say there is a line that is y is equals to mx plus c, and we are saying this line is tangent to this parabola. Okay, it is touching the parabola at one point. At this point, let's say that is p. Y is equals to mx plus c. This is the tangent to the parabola y square is equals to 4ax. Okay. Now, if we will try to solve this two equation just like the previous one to find the point of intersection of the line and the parabola, let's see what we are getting. So here we are having mx plus c. If I will write it over here, mx plus c whole square. In this equation, y I am substituting from the equation of the tangent, equation of the line is equals to 4ax. That means m square x square minus 2m cx plus c square is equals to 4ax. M square x square minus 2m cx minus 4ax plus c square is equals to 0. I am trying to arrange it in the form of quadratic equation. M square x square minus, if we will take common, so it will become minus x. If we will take common, it will become 2mc. 2 also we can take out as a common. Okay, just let's leave it as it is. Plus 4a plus c square is equals to 0. Okay, this is the quadratic form we have created by taking the equation of the parabola and equation of the line. What we are doing now, we are just trying to reach to a condition. Okay, so this is what we got. Now, since we are saying that this straight line y is equals to mx plus c is tangent to this parabola, that means this straight line will touch the parabola at only one point, right? So from quadratic equation, what we know three cases are there. That is discriminant greater than 0, then there will be two roots. If discriminant is equals to 0, then there will be one and only one root. Okay, one real root. When discriminant is lesser than 0, no root. So we know these three cases. Okay, discriminant greater than 0, discriminant is equals to 0, and discriminant less than 0. When we are talking about chord or something, that there we are talking about 2 point of intersection, then we can use this condition discriminant greater than 0. But since here we are talking about tangent, that means discriminant is equals to 0. This case we will take. Why? Because discriminant is equals to 0 signifies that the line is touching the parabola at only one point. There is only one root. Okay, discriminant is equals to 0 means one root is there. Okay, one point of intersection is. So we will be taking discriminant is equals to 0 since it's a tangent. Now b square minus 4ac is equals to 0, which implies that what is b? B is negative 2mc plus 4a. If we will do a square, we just need to do a square of this one. Minus 4, a is what? M square. C is what? C square. Okay, b square minus 4ac is equals to 0. From here we will be getting one condition. Which condition? Let's simplify it more. We will be having a square plus b square plus 2ab. 8 2 times 16, 16 amc minus 4 m square c square. 4 m square c square, 4 m square c square gone. We are getting, if we will take 16a common, we will be having a plus mc. Okay, have we written everything perfectly? Is equals to 0. Okay, Now from here, if we will take either or cases, then from here we are getting that A plus MC is equals to 0. That means M, or we can say that C we are getting here minus A by M, right? Can you see C we are getting minus A by M. So the equation of tangent which we are saying, that is y is equals to mx plus c, that became equation of tangent became mx minus A by M. Getting it? Are you getting it? Just a moment, no? Okay, here we are just expanding this one. Then why we have taken negative sign? Why no one said to me that it will not be negative? You know this formula, no? This is just A plus B whole square formula. A square plus 2AB plus B square. It's not A minus B. Yes. Now only someone messaged. Exactly. I was thinking that why we are getting minus A by M. It is supposed to be A by M only. Yes. Here it is plus. If this is plus, so we cannot take minus common. We will be writing it plus. This is plus and this is minus. Okay. So b square minus 4ac when we are doing, here it is negative. Now we will expand it. Now our 2ab will be negative. So this 2ab will be negative over here. Now 16a we can take out common. It will be a minus mc, and a minus cm is equals to 0. So c will be, if we will change the side, c will be a by m. Okay, and our equation of tangent became this one, mx plus a by m. Okay, we will just keep in mind this rule. This is for the parabola y square is equals to 4ax, but mostly in the, like anywhere you can see in the previous year question paper or in the exam, mostly we will be getting this parabola only, that is y square is equals to 4ax. If not, if that is different parabola, you have seen the process of finding it by taking discriminant is equals to 0 and just taking the straight line and the parabola and solving it. Okay, so from there only we are getting this condition that c is equals to a by m. All right, we will be using this condition again and again. Now let me take one question. Yeah, the question is the equation of the common tangent touching the circle x minus 3 square plus y square is equals to 9, and the parabola y square is equals to 4x above the x-axis is option A, root 3 y is equals to 3x plus 1. Option B, root 3y is equals to negative x plus 3. Option C, root 3y is equals to x plus c. And option D, root 3y is equals to 3x plus 1. Okay, let's see what the question says. The equation of common tangent touching the circle and the parabola also. we have to find the equation of common tangent, which is tangent for this parabola also and the circle also. Okay, this is the parabola we are having. Y square is equals to 4x. That means our parabola will look like this. All right, the circle is having center at 3 0. Okay, so maybe circle is having center over here 3 0, and the radius of the circle is 3. All right, so this is how our circle will look like. Okay, this is just a rough sketch. Now we have to find equation of the common tangent. So a tangent is there which is tangent to the parabola also and to the circle also. So maybe the tangent is coming like this. It is touching the parabola and then to the circle over here. Okay, maybe the circle is going outside, just passing through outside. Okay, this is how the equation of the common tangent, this tangent we have to find. Now here what we will do, now only we have deduced one case, that when we have to find the equation of tangent to the parabola y square is equals to 4ax, the condition is this one, c is equals to a by m. Okay, where this and this way y is equals to mx plus a by m. This is the equation of the tangent to the parabola y square is equals to 4ax. Okay, we will be using it. Now our equation of the parabola is y square is equals to 4x. So what is a? What is a over here? Anyone? If our equation of parabola is y square is equals to 4x only, what is a over here?
1.
Exactly, it is 1. Okay, so in our equation of the parabola y square is equals to 4x, we know a is 1. All right, and the condition of the tangent says that c is equals to a by m. That means c is equals to a is 1 by m. M we don't know. The slope of this tangent still we don't know. All right, so the equation of the tangent will be y is equals to mx plus a by m. That means y is equals to mx is mx plus a by m. This is our equation of tangent. Okay, if we will simplify it a bit, we will be having m. If we will take m as a common on the other side, we'll be having m square x plus 1 over m, like this. If we will simplify it again, my it will become m square x plus 1. We can write it this way. We can write m square x minus my plus 1. Other side we can keep 0. So basically this is how our equation of tangent looks like. M square x, it's a straight line. Okay, m is just a number, it's a slope of the tangent, minus my plus 1 is equals to 0. This is the equation of the tangent we are having. Okay, now we have to find such a value of m so that the same line will touch the circle also. Okay, it will be a tangent to a circle also. Okay, what we have to find here, the equation of the common tangent. This tangent only we have to find. The equation which we have found now, we have to find the value of m over here. Okay, how we will be doing so? So since it is tangent to the circle also, can we say, since this line which we have found from the parabola, the same line is tangent to the circle also, that means from the center of the circle, if we will drop the perpendicular at a point of contact, okay, here if we will drop the perpendicular, this will be equal to the radius of the circle. Okay, radius, that is 3, because the equation of the circle is x minus 3 whole square. This equation of circle is x minus 3 whole square plus y square is equals to 9. 9 means 3 square Radius of the circle we know from the equation of the circle is 3. Okay. So on this tangent, if we will drop the perpendicular, we will be getting the distance will be the radius. Okay. We know the distance formula. Okay. In 3D also we are using the distance formula. The same distance formula we know that will be applicable for 2D also. Distance is equals to mod of from which point? From which point we want to find the distance? From the center of the circle. Center of the circle, that is 3 0. Okay, what is the distance? The distance is equals to the radius, that is 3. Distance is same as the radius, that is 3. From this center 3 0, we are dropping the perpendicular on this tangent line. Okay, on this tangent line we are dropping the perpendicular from the center. Okay, let's write the condition. 3, if we will multiply m with m square, it will become 3m square. Okay, ax plus by plus c. Okay, we put all the values, then 0, it will become 0 plus 1 over under root a square plus b square over under root a square. What is a? M square, that's whole square, plus b square, that is minus m whole square. Okay, the distance we already know, that is equals to the radius. How? From the property of the circle and the tangent. Okay, so the radius is 3 over here. That is the distance we know already, is equals to 3m square plus 1. Here we'll be having m to the power 4 plus m square. Alright. If we will take it out from the root sign, numerator, let's keep it inside the root, 3m square plus 1. Denominator, if we will shift it to other side, it will become m to the power 4 plus m square, like this. Now if we will do is squaring both sides, so here it will be 9 m to the power 4 plus m square, and here it will be 3m square plus 1, that's whole square. Okay, let's simplify it. So we will be having a square, that is 9m to the power 4 plus 2ab. So 3 2 times 6, 6m square plus b square. Here 9m to the power 4 plus 9m square. We can see 9m to the power 4, 9m to the power 4. Here we can cancel it out. Okay. Now we are getting 9m square is equals to 6m square plus 1. So minus 6m square is equals to 1. 3m square is equals to 1. So what is m value? M we are getting as a 1 by 3 plus minus root 3. Okay. Because m square is there. So we are getting two m values. One is plus root 3, another is negative root 3. Now it says the equation of common tangent touching the parabola above the x-axis. Okay, above the x-axis. Maybe there is a the slope of this is one of the tangent, and there is another tangent also, which is common tangent. Okay, for the parabola and for the circle also. So two tangents are there. That's why it is specifying that we need to focus on the tangent that is above x-axis. We have got two slopes over here. That is one of the slope is positive 1 by root 3. Another slope is negative 1 by root 3. We will not be taking the negative slope. When it will say below x-axis, the slope is going down. That time we need to consider negative 1 by root 3. Here we will be taking positive 1 by root 3. Okay. Okay. So m value we know, that is positive 1 by root 3 according to the given condition, that is tangent is above the x-axis. Okay. It is going upward direction. So the slope has to be positive. The slope of the tangent has to be positive. Now equation of tangent was m square x minus my plus 1. So here we will substitute 1 by root 3. So 1 by root 3 whole square x minus 1 by root 3 y plus 1 is equals to 0. So we are getting 1 by 3 x minus y by root 3 plus 1. Let's see how the equation is given in the options. Root 3y, root 3y, root 3. Okay. So let's take LCM as a 3. Obviously 3 means what? Root 3 into root 3. So LCM is 3. Here we will be getting only x. Here we will be getting root 3y, and plus 1 will be only 3 is equals to 0. Okay, the LCM which we have taken, we can shift it to other side and that will be 0. So we will be having x plus 3 on this side, and that side root 3y will be there. Maybe this option is there. X plus 3 is equals to root 3y. Wait, no, C, why I have written C over here? Let me check the options. Yeah, it is 3. Okay, so option C is the correct option. Can you see? Root 3y is equals to x plus 3. Let's summarize everything. Okay, let's see the question. The equation of common tangent touching the circle and the parabola. Common tangent we have to find. We know how to find the equation of tangent to this parabola. Now only we have seen the condition. C is equals to a by m, y is equals to mx plus c. At the place of c, if we will be writing a by m, we will be getting the equation of the tangent to this parabola. Y square is equals to 4ax. Okay, so here our parabola is same, so we are using the condition of the tangent. A we are getting 1 here. C is equals to a by m. So a is 1. So it is becoming 1 by m. Equation of the tangent directly we are able to write. That is mx plus 1 by m. From here we got the equation of the tangent. Now this tangent is also tangent to the circle. Okay, if it is tangent to the circle, then from the center of the circle, if we will drop the perpendicular, that will be equal to the radius. So distance formula we have applied. Equation of the tangent we know, like from a point we are dropping the perpendicular on the line. Okay, this line's equation is the tangent, point is the center of the circle 30, and the distance we already know, that is the radius 3. We have applied the condition and we got the slope of the tangent. One positive slope we got, one negative slope we got. That means one more tangent is there which is below the x-axis. We just need to take the slope which is above the x-axis. So we have taken m as a positive value. We have substituted in our equation of the tangent and we got the equation of common tangent. Is it clear? Is it clear?
Yes, ma'am.
Let me know if it is clear or not. Let's take one more question. If the line, this one is also related to tangent only. Here you will find in previous year question paper, most of the question is related to the concept of tangent or normal. Okay. So the other question is, if the line ax plus y is equals to c touches both the curves, x square plus y square is equals to 1 and y square is equals to 4 root 2 x, then c is equal to option A 1 by root 2, option B 2, option C root 2, and option D 1 by 2. Okay, let's do it in the same way. Okay, so what we are having here, if the line, here the equation of tangent. Okay, if the line this is touching both the curve this and this, okay, then see we have to, this is the line we are having. If we will write this line in the standard form, y is equals to mx plus c, slope intercept form, it will become y is equals to minus ax plus c. Let's keep it as it is for now, and let's apply the same process. We know how to find the equation of tangent to this type of parabola. Y square is equals to 4ax. We know the condition, c is equals to a by m. Okay, so we are having the equation of the parabola y square is equals to 4 root 2 x. Here a we can see in the parabola a is root 2. Okay, that means c will be a by m. A is what? Root 2 by m. Alright. Now here we are having the equation of circle also. From the equation of the line, can we say the slope is minus a? Can we? Can we? Yes. Can we say from the equation of the line, can we say the slope of this line is minus a? Yes or no?
Yes.
We can say. That means whatever we are saying m. Now this m we can take from the equation of line as minus a. Yes, because it says the line, this is not a random line. This is a line which is touching both the curve. Okay, so we can take m as a minus a. C is equals to root 2 by minus a. Okay, this is one of the condition we have got. Let's keep it aside. And then what we did in the previous question, we were having the circle. From the center of the circle we have dropped. Okay, so before that let's find the equation of tangent. Now our equation of tangent will look like y is equals to mx plus c. That means m is minus ax plus c is root 2 by minus a. Okay, this is our equation of the tangent. Let's, which is also given in the question itself. Let's do the arrangement over here. Okay, let's write it in the form of ax plus by plus c. So if we will try writing it like that, this is minus ax, this is minus root 2 by a. If we will take as a LCM, it will become minus a square x minus root 2, and there it will be a y. Let's take this x and root 2 everything on the other side. So it will become a square x plus ay plus root 2 is equals to 0. Okay, this is the equation of tangent we are having, which was already given. Okay, equation of tangent was already given. C we didn't know. We have taken C from the equation of the parabola's condition. We got the C, and that C we are using to frame the equation of the tangent. Now on this tangent, if we will drop the perpendicular from the center of the circle, what is the center of the circle? X square plus y square is equals to 1. What is the center of the circle? X square plus y square is equals to 1. What's the center?
Origin.
Origin is the center, obviously. 0 0. From 0 0 we are dropping the perpendicular on the line a square x plus ay plus root 2. A square x plus ay plus root 2 is equals to 0. Let's drop the perpendicular. Distance will be here, this will become 0 0 0 root 2 over a square, that means a square whole square plus b square, that means a whole square. That is equals to radius of the circle. The radius of the circle is 1. Okay, any confusion so far? Any confusion so far? No. Let's simplify it. We are having root 2 over here in In the denominator, we are having a to the power 4 plus a square. Here we are having 1. If we will change the side crisscross, we will be having a to the power 4 plus a square. And here we will be having, okay, when we will do is squaring both sides, here only 2 will be having. That means we are having a to the power 4 plus a square minus 2 is equals to 0. Now we need to factorize it so that we will be getting the value of a. Once we will get a, then only we can find c. Okay, can you see c is root 2 by a? So we want to find a over here. All right. So a to the power 4 plus a square, if we will try to factorize it, can we write this a square as a to the power 4 plus 2a square minus a square minus 2 is equals to 0. Let me check whether it is possible or not. If we will take a square common, we will be having a square plus 2 over. If we will take minus 1 common, we will be having a square plus 2 over. Yeah. Yeah, we are just splitting the middle term. Can you see it? Is it clear? Yes or no? Are you getting it? We are just splitting the middle term over here. Getting it?
Yes.
Let's move ahead. So we are getting a square plus 2 and a square minus 1 is equals to 0. A square plus 2, if we will find value of a from here, okay, it will give imaginary roots which we don't want. If we will take a square minus 1 is equals to 0, we will be getting a square is equals to 1, a is equals to plus minus 1. Okay, a we are getting plus minus 1. What we have to find? We have to find this mod of c. Okay, c is root 2 by minus a. C is root 2 by minus a. Okay. So a plus value or minus value, whatever we will be taking, we need to take the mod of c. We need to find the mod of c. Okay. We need to find mod of this one. That means mod of the other side. All right. So whatever we will be taking a as a plus or minus, it doesn't matter. Root 2 we will be getting as an answer. Yes or no? Option C is there already, root 2, and that is the correct option. Let's see what we did. So here we are having equation of the line touches both the curve, then C. Here, just like the previous one we have done, okay, we have found the equation of the tangent to this parabola. Okay, whatever equation of the tangent we have got from here, there m was there, which is unknown. Now here we know that m is minus a, that only we have used from here. Getting it? And simply we have created our equation of the tangent. The way we have dropped the perpendicular from the center on the tangent, that will be equal to the radius. Same thing, we have same condition we have used over here, and we ended up getting a as a plus minus 1. We needed to find mod of c, so we are saying whatever a value we will take, plus 1 or minus 1, eventually root 2 will be the answer. Is it clear? Yes or no?
Yes, ma'am.
Okay, let's take one question from normal. Now one of the question is like this: consider the parabola with vertex 1 by 2, 3 by 4 and The directrix of the parabola is also given as y is equals to 1 by 2. Let P be the point where the parabola meets the line x equals to minus 1 by 2. If the normal parabola at P intersects the parabola again at a point Q, then PQ square is equal to, options are 75 by 8, 125 by 16, 25 by 2, 15 by 2. Okay, let's see what the question says. Consider the parabola with vertex. We know the vertex of the parabola. This is the shifted parabola where the vertex is shifted. Okay, the vertex is not the origin. Directrix equation is also given over here. Let P be the point where the parabola meet the line x equals to minus 1 by 2. Okay, the parabola equation we don't know here, but P is the line which meets the parabola at x equals to minus 1 by 2 will be this line, x equals to minus 1 by 2. Alright. Equation of the directrix y is equals to 1 by 2, that also we can plot. Right. This is how our lines will look like. If the normal to the parabola at P intersect the parabola again at the point Q. Okay. So we are having the vertex of the parabola 1 by 2, 3 by 4. That means this is origin. This is origin 0, 0. If x is 1 by 2 over here and x is y is 3 by 4. That means somewhere here. Okay, somewhere here is the vertex of the parabola. That is 1 by 2 and 3 by 4. Alright. We are just trying to plot the rough sketch so that we will understand the question perfectly and then we will try to solve it. So vertex we have pointed over here. Now we will plot the equation, plot the parabola. So directrix is 1 by 2. That means the parabola will face upward, right? This is the vertex. Maybe this is how our parabola will look like. Why I am joining it with red line? Because here it says that parabola is touching this line at P. Read it. Consider the parabola with this vertex and this directrix. Let P be the point where the parabola meet the line this. P be the point where the parabola meet this line. Okay, so parabola is meeting this line at P. That's why our parabola, I have drawn it like this is the vertex. However, in my figure it doesn't looks like the vertex, it should be in the middle, but take it as a rough sketch. Vertex is this one, 1 by 2 and 3 by 4. Okay, Now what does it says? If the normal to the parabola at P intersect. Okay, so at P there is a tangent like this, and from here we are dropping the normal to the parabola, which is intersecting the parabola again at a point Q, which is intersecting the parabola again at a point Q, this normal PQ. Okay, then the length of this PQ is square we have to find here. All right, again consider the parabola with the given vertex, given directrix. P be the point where the parabola meets x equals to -1 by 2. From that point we have to drop the normal to the parabola. Okay, that, and there that normal is intersecting the parabola again at a point Q. We have to find the length of PQ. That's what the question says. At P we know x coordinate is -1 by 2. We don't know the y coordinate. We will be able to find it by using the equation of the parabola, because P is lying on the equation of the parabola. P is touching the equation of the parabola. So y we will be able to find from the equation of the parabola. But first thing first, where is the equation of the parabola? We don't have equation of the parabola. So what we will make the equation of the parabola. Here we can see in our rough sketch, our parabola equation will look like this one. X square is equals to 4ay, where x is the shifted vertex. That means x minus 1 by 2 whole square is equals to 4a. Y is y minus 3 by 4. This is our equation of the parabola. Do we know the focus A? With the help of directrix, we will be able to find the focus. Okay, we know this point here. Let me mark properly. We know this one, this green line, this green point here. Y coordinate is 3 by 4. Okay, and we have drawn the purple line, or you can say we have drawn this green line. This green line here, y coordinate is 1 by 2. Okay, 1 by 2. So whatever is this distance here, the focus will be the same distance. That's what the directrix signifies, right? So we will be finding the distance. Total is 3 by 4. This much is 1 by 2. So 3 by 4, y coordinate minus 1 by 2, y coordinate will give 4, 3 minus 2, that is 1 by 4. So this distance is 1 by 4. Upward also it will be 1 by 4, we can say. And if we will take the 4 times 1 by 4, our equation of the parabola will look like equation of the parabola will look like x minus 1 by 2 whole square is equals to y minus 3 by 4. Is it clear so far? Is it clear so far how we are getting the equation of the parabola? Vertex is given. With the help of directrix, we are finding the focus also, and then we are writing our final equation of the parabola. Is it clear?
Yes, ma'am.
Okay, let's move ahead. So this is our equation of the parabola. We know point P, at a point P, x coordinate is minus 1 by 2. We can find y coordinate by using our equation of the parabola. X coordinate is minus 1 by 2. At P, x is minus 1 by 2. So if we will substitute minus 1 by 2 over here, we will be having minus 1 by 2 minus 1 by 2. That's whole square is equals to y minus 3 by 4. So we will be having minus 2 by 2, that means negative 1 whole square, y minus 3 by 4. So it will give only 1 plus 3 by 4, that is y. So y will be 7 by 4. When x is minus 1 by 2, y is 7 by 4. Okay, we got the coordinate of point P. Okay, we just need to find Q, then only we will be able to find PQ square. What is PQ? It's the normal to this parabola. What is the equation of normal to the parabola at a point minus 1 by 2, 7 by 4? So equation of normal to the parabola. So equation of the parabola was x minus 1 by 2 whole square is equals to y minus 3 by 4. This is our equation of the parabola. First, we will be finding the slope of the tangent. Okay, slope of the tangent will be, if we will do derivative on both sides with respect to x, it will become 2x minus 1 by 2 on this side. Chain rule again x we will do, that will be 1. That side it will be dy over dx. So we got this as a dy dx is equals to 2x minus 1 by 2. This is the slope of the tangent. Okay, if we will be finding the slope at P, P is what? P is minus 1 by 2, 7 by 4. P is minus 1 by 2, 7 by 4. So it will become 2 minus 1 by 2 minus 1 by 2. That means again minus 2 by 2, that is negative. That is negative 1. So we got the slope of the tangent as minus 2. What will be the slope of the normal? Just the reciprocal of this one with negative sign. Yes or no? We know when two lines are perpendicular, their slope m1 into m2 is equals to minus 1. Right? Do you know that?
Yes, ma'am.
So slope of the normal will be minus 1 by negative 2. That means 1 by 2. Okay. Now equation of the normal by using point slope form. Equation of normal will be y minus y1. What is y1? The same point P. There only by using that point only we are just dropping the, we are making the normal. So point P is minus 1 by 2, 7 by 4. Minus 1 by 2, 7 by 4. That is P. That only we are using to find the equation of the normal. Okay. So minus 7 by y minus y1 is equals to m. What is m? Slope of the normal is 1 by 2. X minus x1. This is our equation of the norm. Let's simplify it. We will be having y minus 7 by 4 is equals to 1 by 2x plus 1 by 4. Okay, anyway, we need to take the LCM. If 7 by 4 also, if we will take it in this side, it will be plus 7 by 4. So this is becoming 8 by 4. Okay, 2 times 2x plus 8. However, we could have cancelled also. Let me cancel it better. But anyway, we have to take the LCM even if we will cancel it out. Okay, LCM is 2, x plus 2, y. So our equation is 2y is equals to x plus 2, x minus 2y plus 2 is equals to 0. This is our equation of normal. So far, is it clear what we did? By using the given condition, a vertex and the directrix, we found the equation of the parabola. That parabola is touching point P, where x coordinate is minus 1 by 2. So by using the equation of the parabola, we also found the y coordinate of the point P. That is 7. Now we are finding the equation of the normal. So point slope form we are using y minus y1 is equals to mx minus x1. M should be the slope of the normal. slope of the normal, how we will get? First we can find the slope of the tangent from the equation of the parabola, and then we can do the reciprocal with negative sign to get the slope of the normal. That we can use for finding the equation of the normal, and we got the equation of the normal by using point P as this one. What we want to do here, we want to find Q also, so that we can go ahead and we can find PQ. See, we have to find the length of this PQ square. We have to find P. We already know in the first few step only we have found the coordinate of P. We are just worried about the coordinate of Q, and that's why we are finding this equation of the normal, so that now we can solve the normal equation and the parabola equation to get the point of intersection. Are you getting me? If we will solve the equation of the normal and the equation of the parabola, we will get the point of intersection, and that point is point Q, we can say. Getting it? Are you getting?
Yes, ma'am.
Let's solve it. Equation of the normal we are having in hand. Equation of the parabola is x minus 1 by 2 whole square is equals to y minus 3 by 4. X minus 1 by 2 square is equals to y minus 3 by 4. If we will do substitution, which will be easier. Here if we will take x equals to 2y minus 2. If we will substitute it over here, 2y minus 2 minus 1 by 2 whole square is equals to y minus 3 by 4. 2 times 4 minus 1 minus 5 by 2 whole square is equals to y minus 3 by 4. Please solve it, no? Or is there any easier way to simplify this too? Let me check. Anyway, we will be getting quadratic. Okay, even if we will take y from here and we will be substituting it over there, still it will be quadratic, right? Let's do it that way only. Okay, if we will be taking y from the equation of the normal and we will be substituting it over here, what we will be getting? Y is equals to x plus 2 by 2, right? Yeah. Let's simplify it. So we will be having 4, 2x plus 4 minus 3. Here a square, or we can take LCM on the other side also. Okay, let's take LCM. LCM is 2. It will be 2x minus 1. That's complete square. If we will just take it out the denominator, it will become 4. And this side is also 4. 4 and 4 we will cancel it out. It is not minus 4. It is just 4. Okay. So 4 and 4 will cancel it out. We will be having 2x minus 1 whole square over there. And here we will be having 2x plus 1. Let's do that. A square minus 2ab plus b square, 4x square minus 6x is equals to 0. Alright. If we will take 2x common, we will be having 2x minus 3 is equals to 0. So we got x equals to 3 by 2 and we got x equals to 0. Please check the calculation now. Are you getting the same after doing the substitution from the equation of the normal? Please check it. What are you getting as a Q? We just need to solve the equation of the parabola and the equation of the normal. This is the equation of the normal. Check what coordinate you are getting for point Q. Are you doing it? Everyone, are you doing it? Yes or no? What you got as a point of intersection from the equation of the normal? Here, have you seen we were having 2 as a LCM, so this will be 4, not 2. Okay, we would have taken 4 over there. What you got, let me know. Are you solving it? We are getting 4x square minus 6x minus 4 is equals to 0. That means 2x square minus 3x minus 2 is equals to 0. 2 times 4, we can split the middle term. We can write minus 3x minus x. No, 4x minus. We can write it as a minus 4x plus x. We got x minus 2, we got 2x plus 1. From here we are getting x value 2 and minus 1 by 2. Minus 1 by 2, I believe that is the coordinate of point P, because the normal is touching point P also. So minus 1 by 2, we already know that point. X equals to 2, this point we will be using. Okay, our equation is y is equals to x plus 4 by 2. Equation of normal is y is equals to x plus 4 by 2. Here we will be using x coordinate, which we have got 2. So 2 plus 4 by 2, 6 by 2, 3. When q we got, when x is 2, then y is 3. We just have to find pq square now. Alright, pq square we have to find now. P we already know, minus 1 by 2, 7 by 4, and Q we have found 2 and 3. Minus 1 by 2, 7 by 4, and Q we know 2, 3. We just have to find the distance. Okay, square root we will not take because the square we have to find. X2 minus x1 whole square plus y2 minus y1 whole square. Okay, 5 by 2 whole square, that means 25 by 4. 12 minus 7, 5 square by 4. We will take the LCM 16 over here. 25 if we will take out as a common. For the first term we will be having 4, other term is 1. 125 by 60. 25 into 5 by 16. 125 by 16. Are you getting the same? Please do the calculation with me. Okay. From the very beginning, when I explain the term, when you see, you can find the distance, you can find the point of intersection. Please do that so that we will not miss any sign, we will not miss any number over here. All right, we are getting 125 by 16. Let's see that is there in the option or not, and tell me first, you are also getting the same or not. 125 by 16 is there in the option, that is the correct option. Have you done this one? All the calculation, finding the equation of the parabola, then finding the point P, x coordinate we know, y coordinate we have found here, and then the slope we have found, which you already know. Equation of the normal we have found by using point slope form. Y minus y1 is equals to mx minus x1. That formula we have applied. We got the equation of normal. Now the normal is touching the parabola at a point P and Q. So we are solving normal and parabola's point of intersection. We are getting 2 point. 1 point we already know, that is P. Another point Q we just want to find so that we can find PQ square. We have found PQ square. We got the coordinate of Q as a 2, 3, 2, 3, and we got PQ square. Have you understood the whole process? Yes or no? Let me know. Have you understood? Anyone having any confusion over here? Any confusion? Now there is a question which says that I'm just giving the hint for this question. Do it by yourself. Okay. A tangent is drawn to the parabola y square is equals to 6x, which is perpendicular to the line to x plus y is equals to 1. Then which point doesn't lie on the line? Then which point doesn't lie, a moment, on this line? Few points are given over here. We need to check which point. Let me give the points also. So the points are minus 6, 0, 4, 5, 5, 4, and 0, 3. A, B, C, D. Here C. Here we are having a tangent is drawn to this parabola. We know the equation of parabola looks like that parabola only, which we have done the discussion for the tangent. Here 4ax, if we will compare with 4a, a will be 6 by 4, 3 by 2 we got as a. Now the condition for tangent is c is equals to a by m. We will be using that. Then we will be getting the equation of the tangent, which is perpendicular to this line. From the equation of the tangent, okay, we are getting the slope of the tangent, obviously in terms of m. Okay, our equation of the tangent will look like y is equals to mx plus c will be a by a is 3 by 2 a by m. Okay, this is how our equation of the tangent will look like. Here the slope of the tangent we are having as a m, which is perpendicular to this line. That means slope of this line and slope of this line, if we will do the product, if we will multiply that, the result will be -1, right? So with the help of the other line, we can find the slope of the tangent. Yes or no? Once we will get m, we will be able to say this is the equation of the tangent. Now which point doesn't lie on this line? We need to take one of the point, we need to substitute it over here, we need to check it whether it is satisfying the equation or not. If it is satisfying, it is lying on the line. If it is not satisfying, it is not lying. You will find that all the points are satisfying this equation of the tangent except one point, that is the answer. That point doesn't lie on this line. Is it clear? Is it clear? Let me know. We found the equation of the tangent and there is a line which is perpendicular to that tangent. So we can say the product of the slope will be -1. With the help of that, we will be able to get the value of m. That we can substitute in our line and we will get the equation of the line, equation of the tangent line. Okay, now we can check the point which is lying on it, which is not lying. Is it clear? Any doubt over here? Clear? Yes or no? Will you be able to do that by yourself? Please try it. You will be able to do. Okay. We are just using the same condition of the tangent, that is c is equals to a by m and then the equation of the tangent. Alright. Now I am keeping it this much. And again, conic section, few more topics are left. We will be continuing it in the next class. Meanwhile, I will give question for practicing. Please do practice and let me know if you feel any confusion, if you feel any doubt in any of the questions over here. Okay. So keeping it this much, take care of